Good morning to all of you. Okay. Good morning, Sheldon. Good morning. So, good morning, everybody. Good morning, good morning. Let me take. So, what we are doing currently, ML. You are aware now the supervised learning and the unsupervised learning. These are the two different categories. Into the supervised learning, already there are two categories. Remember, regression, and the classification. Inside the regression, there are two parts. Linear regression and the logistic regression. Now, already you done one of the two samples of the linear regression for the hours grade concept as well and the postal house price prediction as well. So you might be knowing now that in case of linear regression, when we are coming with a linear regression, when we are looking for a continuous valued output. There are many x1, x2 input features are there and the label is there to predict the house. What we are finding out, my target is to find the house prices. So whatever I am looking for, whatever I'm searching for, that would be the output variable. Whatever I'm searching for, whatever I'm looking for, that would be the output variable. Label, output variable or Y part, right? And when we are going for the linear regression, when I am looking, the output variable value should be continuous. It means it should be decimal values. Continuous values. Remember the concept? Okay. So when we are approaching the linear regression, whenever we are trying to find out prices, costings, temperature, right? Doctor fee, school fees, aviation price, flight prices. Okay. So in that way, we can use or the disease progression, diabetes disease progression, that what are the new values for the whether the diabetes is progressing. So those continuous values. So whenever we are looking for the output as a continuous value for a y, that becomes linear regression. So here we can apply directly the linear regression. Now coming to the second approach, logistic regression. In case of logistic regression, whenever I am having only two outputs, it means suppose I am looking for logistic means logic. Logic means two. Yes or
no.
True or false. Only two outputs. Whether tomorrow you will go to office or not, whether it will be rain, yes or no. Okay. So in this way, we are looking for the yes or no targets only. Whether the person is having a diabetes, yes or no. Whether the person is having a cancer, yes or no. So either 0, 1, yes, no, true, false, only with two. That comes under the logistic regression. Logistic. Okay. So here, in case of logistic, what type of situation arises that see now you know, like you worked onto the data here, and you know, wait, wait, don't jump, Sanket, don't jump. Hey, I suppose this is a case. So right now what is happening, the goodness of fit is just approaching the best fit line where most of the points are onto the line. So this comes under the linear regression. So whenever data is in this way, so system is approaching, your model is approaching the best fit line. Now there is a case. Suppose my data is not in this way. My data is in this way. Here and some of the data here. Some of the data here, some of the data here. Now what I am trying, let's put a linear regression here. What linear regression will do, it will try to approach the best fit line. Model is learning only 2 points. Model is learning only 2 points. Model is learning only 2 points. Though there are 10 points, more than 10 points, but model is learning only 2. It means model is not learning anything. Because here, the output which is coming here, the data which is spread its visualization is totally different. The spread of the data is totally different here. Okay. So in this case, if we apply directly linear regression, so in that case, okay. So here in this case, here we are having the model is learning only 2 points. The model is learning 2 points. So linear regression approach is not fixing here. It means we should find out certain another solution where the model can learn more. So linear regression approach is not fitting here, right? And certain time what happens, suppose my data is coming in this way, for an example, maybe here, and some of the data in negative completely. So in this case, again, if one is putting that approach, see this approach, see, linear regression approach. Again, model is not able to learn the points. If it is not learning, there is no use of the model. So here in this approach, we should apply certain other techniques so that model could learn. So here, instead of this one, this linear regression, if we apply here, see this one and this case. This is known as a sigmoid. Whenever we turn the data in this way, whenever we turn the data in this way, some of the data here and some of the data here, okay, instead of applying the linear regression, if we are approaching another approach here and then here, okay, so this approach is much more appropriate and we call this approach as a sigmoid. Sigmoid, right? Sigmoid is nothing, that one is just a reverse of linear regression, log of linear regression, log of linear regression, okay, or log out of linear regression. Now, suppose this is one condition, so we do call this situation as a sigmoid, or certain time we call it a logit also, or sigmoid, anything. Second thing also, whenever this comes here, the data is here and data is here, right? So this also situation arises here. So your model learns in this way. So it is just approaching all the points, right? So this is known as a tan H. That is into the higher one, but I'm talking about this one is a basic one. Basic. So we do call this type of situation that my data is in this form, either 0 or 1. You are now getting either 0 or 1. Okay, either 0 or 1. So in this situation, here this one is a 0 almost, I can say, and this one is a higher one, 1. So 0.5 is the threshold values. So it means all the data which are above, that is 1, above 0.5 that is 1, and below that is 0 data. So it means if we can say this is yes, this is no. Okay, so it means we can predict it here. Suppose for the diabetes case, okay, that whether the person is having a diabetes, yes or no. So if the patients are coming into this range, 0 range, it means they does not have the diabetes, and if they are coming into the higher range, they all are having a diabetes. We can predict it for the cancer case also, that whether the person is having a cancer or not, or we can say the person is into the risky state. Risky state means they are having a high cancerous state or the below state. So in these cases, there are only one, that whether the people has lost the life here. If the lost cases are here, they are high. If they are still alive cases, they are here into these states, right? So it means the point is that in this situation, whenever we are having the data, or whenever we are having in the data into the 0 and 1 case, and we are trying to predict only 2 things only. So one should understand that we are not predicting any regression, linear regression here. We are not looking any continuous values. We are just looking for the logic values. We are just looking for the yes or no values, true or false value, 0 or 1 values. In that case, directly we can apply what? Logistic regression. And we can apply the linear regression where the data is we are looking for the continuous values, the key differences. You should remember this point for always. Now here we can directly apply that we can train the model. So there are various models. Basically, logistic regression is the model where it will learn these points. And logistic regression is just the log odds of the linear regression. That's all, and nothing more than it. Now there are internal libraries. Used for the logistic regression. Just like you call for the linear regression, there is an internal library for the logistic regression, right? And then, see here, we have to see certain more cases. Let's move into the depth of it. Here we have to see, for an example, suppose I am having, the approach will be similar. To just evaluate any data set, the approach is similar. Okay, and in that approach, what you are doing in that approach, initially in any data set, you are making the exploratory data analysis. It means you are watching each and every column with a different features. Okay, it means you are understanding the data, right? And then once you understand the data, later on you will be sending the model for the learning, and later you are predicting the new data sets, the unseen data sets. So here, now suppose I am having 100 rows, total 100 rows. Okay, I'll take much better, 1000 for an example. You are splitting the data set into the training and testing, right? So it is up to you, students. You can take it for the 70% or the 30%, or you can make it for 80% or 20%, right? Whenever you are using a train test split. Okay. So suppose I had taken 1000 here. So here, if I'm using the 70-30 approach, so what will happen, 700 data set will go for the training purposes. Okay, so this will be X train, and this would be good X train and Y train, and this would be the X test, and this would be the Y test, right? So it means among 700, 300 data are going for the testing purposes. If we are having a 1000 rows, calculating it, internal calculations I'm doing. Now here, where you are sending the X train into the fit model, fit is during the while training the model. Okay, you are sending this X and Y train while training the model of it. So if suppose there is a logistic regression is the class into the sklearn.linear model. So suppose I am making the LG is an instance, LG.fit, and passing the X train and Y train, so model will learn. Once your model will learn, once your model is learned here, then we are sending the model for LG.predict. Okay, you know very well inside the LG.predict you are sending only X test data for the testing purposes, prediction phase, right? So how many rows are going for the testing purposes? 300. How many? 300 rows are going for the testing purposes. Now what? It will give certain result, predicted result, right? Now here, there are three things we have to check out here in this case. One is the accuracy score. Remember, whenever we are talking about the logistic regression, this is a part of classification. Here we do use the accuracy score. Accuracy score, it means how well my model is working, right? The second one is a confusion matrix. Confusion matrix is just like in this way, where it will show the matrix of the data. What is the matrix of the data? Such like here actual and here predicted. This predicted one. And here is for the 0, 0, 1, 0, 1. Now suppose 300 rows I had sent for the testing purposes. So here, out of 300, it says, suppose this one is the case I am taking for the cancer prediction. Okay. So it is predicting that within the 1000 people's data, how many people are affected by the cancer? Yes or no only. So there, suppose this one is there, so we had sent the 300, so predicted result was for the 300. What this says, suppose, it says 200 here into the confusion matrix and 100 here. Remember carefully. Suppose this is the case. It is saying 0, 0 means 200. 200 among from this 300, 200 people does not have the cancer, and this 100 people does have the cancer case. So we have to see the data diagonally. This we call it a confusion matrix. Okay, and here the values will be 0. These are the error values. Error values means the data, the model is not learning well. Okay. So suppose my accuracy score, I will check out the accuracy score also, accuracy score. So what is that accuracy score? Accuracy score, suppose I am saying my accuracy score is 1.0. It means 100%. 1.0 means 100%. It means it is saying that my results are 100% okay. 100% okay. It means my model is learning 100% correct. My model has given all the answer correct. So that one is 200, 100 means 200 cases with no cancer, 100 cases with a cancer, and 0, 0 here. It means model is working 1.0 means 100% right. Now suppose accuracy score is somewhere 95. Accuracy score is showing me 0.95. So here into the 0.95, what I'll do, I'm changing the confusion matrix. It means my model is learning only 95%. Okay. So here suppose I'll say 190 cases with no cancer, 10 cases are doubtful cases. Here and into the yes cancer cases or true cancer cases, so here it will be, suppose I'll say 85 people with cancer and 15 people with doubtful cases. So it means these terms which are 190 and 10 here, whenever we are getting any value here, okay, so these values are false values. It means that the machine is giving certain answers, but machine is not confident with the answers. Machine is in doubtful case. Here also machine wants to say that 85 people are, yes, truly they are having cancer, but 15 cases are totally doubtful whether the person is having a yes cancer or not. It means machine itself is in the not right case, that's why those cases do put into the error cases here. It happens a lot of times. Student is giving the answer, but he is not sure with the answer. 100% he is not doing right answers. Somewhere, some answers are right, and in some answer, half of the answer is correct, half of the answer is wrong. So what to do with this data? It means it is not 100% right answer. So certain time it happens in the machines also. So whenever it happens, whenever we are getting values into the error case, so these are the errors. Error 1, error 2 types also. Okay. Now you can map easily all this confusion matrix from the hypothesis testing also, if you remembered. There also we had seen this classification map. So that's why there is also data, here is also data, one can map all the statistics here. Here we are using the various mathematical formulas which is being used into the novel statistics. There is also data, here is also data, but here all the data, all the mathematics which we are doing, that has been put it into the Python code only. And one has made the library and one is using the data analysis there. Right? So in this way. The third one is the classification report. Okay. So classification report will give you the accuracy score and many more other things. Slowly I'll be conveying it. Right? But for the time being, one should understand that whenever I am looking for the output in the form of yes and no, that is the output variable, label. There we directly use the logistic regression. There is an internal module, sklearn.linear model, and inside that logistic regression class is also already there. We send the data for the learning and later on for the testing. In the response, it delivers us accuracy score, confusion matrix, and the classification report to test out the results. And then later on we can improve the results. Okay, right? So this approach we are taking. You might be remembering when we are using a linear regression, whenever we are looking for the continuous valued output, when we are using the logistic regression, whenever we are looking for the yes, no outputs. Yes. Now I'm taking for the now you can see it here, the same one which I described it here. Okay, if I am having these cases, so directly your model will learn, your logistic model will learn it this way, right? Yes or no cases, survived or lost cases. Means the same one we can use is for the diabetes prediction also, or any other yes or no cases. Whether the person is having the diabetes, whether the person will go out to play, yes or no, so in these conditions here. So here this one is a linear regression that is not feasible here. Here also linear regression can't be put. This one is a linear regression, we can't put it here, that is not successful here. Okay, so here what we are doing, directly we are taking this approach, logistic regression, blue lines, logistic regression approach. Okay, logistic regression approach here, and this is just the log odds of linear regression. Okay, wait, here this one is the formula given for the logistic regression. This one is the log odds of your linear regression. Just okay. This one is the formula for the logistic. One can see it. Now here the similar one here the classification is going on. Classification is going on for what? For the two type of diseases, whether the person is having the cancer or no cancer. So in this way the data will be there and machine will be making a classification on its own. Okay. Now here we are having the from sklearn linear model import logistic regression. Okay, and then we are using the logistic regression, training the model and predicting the model, right? The similar way you did with the linear regression. And here, okay, let me tell you this now. Now it is here. Now for the error matrix also, like you know, into the linear regression what you did. Now when you did with the linear regression, and now I am saying the logistic regression, see the key difference between two. Whenever we are measuring the matrix for the linear regression and the logistic regression, inside the linear regression we are checking the R2 score. That is the coefficient of determination that is conveying you that how much your y is being varied whenever x is being changed, inputs is being changed, right? And the second one, you are looking for the mean squared error also, MSC. Mean squared error also you are checking it out. Okay, fine. So through this you can check it out that what is the score and how much is the mean squared error, how much error is there, one can improve with it. Second thing, into the logistic regression, we can check out the accuracy score, the confusion matrix, right, and the classification report. Now one can see it. This one is a confusion matrix. Wait, here. This one is a confusion matrix. In this way, you will be having a confusion matrix where all the actual data and all the predicted data will be there. So here all the true positive and here all the true negative cases, and here these are the errorful statements, errorful data. That would be false negative and false positive. So these are the data which is in type 1 and type 2 errors. This one is the type 1 and type 2 error, and we have to check the diagonal data. Okay. Just a moment. Okay. Now here you might be knowing now. See these one. All the data, the true positive will be here, and the data which is here in the false negative. So if we add it, that becomes a true total actual positive. Why? Because if here suppose I am having 100 cases for the testing purposes, so 70 cases are 70 cases are here, 5 cases are here, okay, and here 35 here, 20 cases are here and 5 cases are here. So it means that 70 plus 5 is 75 cases. It means that the system wants to say, if I am taking it into the diabetes case, suppose the system wants to say that 75 cases are with no diabetes, but with 70 people I am assured, but with 5 people I'm not assured. But the total data is what? Whatever data is coming here and whatever data is coming here, that it is added, that becomes a total actual positive. And all the data which is lying here. So this one is the exactly right data, which model is understanding well, but this one is the data which where model is getting doubt. So if we add both of them, that one is the total actual negative cases. Okay, but these are the errorful cases, it happens. Means some of the answers are correct, some of the answers are wrong. Now, what is the accuracy score? Your accuracy score is basically that how much your model is learning well. This plus this. True positive plus true negative. True positive plus true negative. Okay. So true positive plus true negative. Okay. And divided by all four. So this is what? This was the accuracy score. The right answer, like in your marks, your papers also, how you are getting the marks. Suppose one is getting 80 out of 100. 100 is the total marks. Yes, and how much you make it correct. So your corrections are here into the true positive and true negative. So that is being added here. So true positive plus true negative, this plus this divided by whole, that becomes your accuracy score. That how much your model is working well, that becomes your accuracy score, right? Now there is a true positive rate. What is true positive rate? True positive rate is true positive over true positive plus false negative. True means how much your data is actually working with true positive. So that is the true positive over true positive plus false negative, right? And here is also false negative rate is what? False negative rate is what? That one is your your false negative over true positive plus false negative. It means this one is the right data. This one is your doubtful data, means error data. So your true positive rate is true positive over true positive plus false negative, and false negative rate is how much this data is coming. Okay, divided by both of them. Okay. Now one can see here that to find out the true positive rate, we can call it a true positive rate also, and we can call it a recall or sensitivity also. Anything. Recall or sensitivity also to whom? That how much your model is corrected well and how much your data is having the errorful cases also. That so how much your total model is working well with the errorful case and the actual cases. So this is known as a recall or sensitivity also. One can call it a true positive rate. So these are internal definitions defined it internally. Then there's a precision. Your precision is what? That is a true positive over true positive plus false positive. So internal function, internal metrics are there which will be calculating everything. So you will be getting there that what is the recall value, what is the precision value, but internal formulas they are taking this one. That the precision is true positive over true positive plus false positive here. Yes. Right? Okay. And this one is what? Specificity. Specificity is what? Avoiding false alarm. So how much is your data? True negative over false positive plus true negative. This one is the specificity. So one should know sensitivity, specificity, precision. So these are values which will be your matrix will be calculating internally and will be delivering as a classification report. It will deliver to you. So if in overall one can see here that what is the accuracy, what is the precision. So one can see now all these. Accuracy, this plus this divided by whole. Recall or sensitivity, true positive over true positive plus false negative. Precision is true positive over true positive plus false positive. And specificity. Now there is a F1 score. How this F1 score is well calculated? 2 into precision into recall divided by precision plus recall. So how we will get all these values? There is an internal measurement matrix is given with a classification report. Classification report is given there. Okay, all the values will be calculated internally. Getting? So initially you will be getting in this way only, these two, right? So we will be getting for the classification error matrix from sklearn.matrix, import accuracy score. From classification.matrix, import accuracy score, confusion matrix, classification report. All three. Okay, and then we can call the accuracy score passing on which data? The predicted data and the testing data. Right? And one can check out all these values. Let's take a sample here. Now I am taking one of the very simplest sample here. I am taking the cancer case. The data set which we are taking, that is available into the scikit-learn data sets. These are the actual cancer cases. All the values are taken from there, right? Now here, one can see the libraries which I am calling here. NumPy, datasets, this one is a load breast cancer. Linear model I am calling here. sklearn.linear model imply logistic regression. Now here see these three values, you can check it out. sklearn.matrix, accuracy score, confusion matrix and the train test split. So accuracy score, confusion matrix and the classification report. I am taking all these three for the checking purposes. I am loading the data, checking out the data. So inside this data, many values are there. These are coming into the NumPy array initially. And one can see the output here. This one is the output here, target. Target is the output here with 0 and 1 values. And these are the input X. And these are the Y. Very good. So in this way, one can check out the names also. One can check out the name of the target names, malignant and benign, either 0 or 1. And here, one can see, if you read in detail, number of instances are how many? 569 rows. Instances means rows. And number of attribute how many? 30. 30 column internally. Now here, what one can do, see, if you check it out, many details are there. Attribute information means column information, data information. Radius, texture, perimeter, area, smoothness, compactness, concavity, it means severity, concave points, symmetry, coastline. Okay, and one can check means 30 attributes they had fetched it out. And then they had detected whether the person is having a cancer or not. Right? Okay. Here, if you can read it, complete details, okay, of the data set being taken by the scikit-learn. One can check it out. All these, see, these are the feature names given here. Complete details are given there, certainly. Right? But internally, from where it is fetching, you can see it here. When we do install the Anaconda, automatically sklearn will be installed. And from there, the internal library is dataset, and inside the data, your CSV files are there. Getting? So from there, it is fetching out the data. Okay. Here we are taking out the keys, whenever the data is being fetched from the data set, so that will be coming into the dictionary format. Okay, how you are recognizing? You can see it. See, this one is the dictionary format. See this one here. So data is a key, target is a key, and these are the values. Key value pair. And you can see it at the end, it is just showing curly braces. It's a dictionary element. Now you are taking out the keys, so it is saying data, target, and all this. Now what you can do, I'm taking it one by one. I want to see data.features name. I want to see data.keys, data.target names and all. Data.feature names, right? So these are the feature names, these are the actual data, input data or of 30 attributes into the NumPy array format. And you might be knowing, because this is a very lengthy, you can see dot itself means there is a lot of data in between. Because it can't be displayed on the screen right now. But one can put it into the data frame to check it. Data.target, all 0 and 1 values are there. For 569 rows. Descriptions are given there. I am taking out all the data in what? Data. Means data frame I am putting. Right? It is just showing it. I am taking it into the cancer data. Okay? It is just showing, see, all the attributes, all the values are there. Many values are there. Nearby, how many columns are there? 0 to 29. So here one can see 569 rows and 30 columns are there with the data frame. I can check it out with the period or data frame data.target also. It will be showing into the tabular-like structure. See 01, 01, 01 are there. So this one is the target. Target means whether the person is having a cancer or not. Yes or no, 0 or 1 values. So 2 values are only there for the logistic regression. Remember these points. Okay. Now what we are trying to do, we are taking the data into the X and Y format. X and Y format. So we are putting the data, cancer data into the X input. Okay. And we can put the cancer target into the Y output label. Data target into the Y. Okay. Now here what I am doing, see, basically here you have to apply your own EDA process now. You have to do your own EDA process. You must be doing that part on your own. Data set is there. Check out each and everything on your own. Later on you can add it. Complete EDA process you can do it. Finding out the null, finding out the D tags, finding out the checking out univariate analysis. One by one you can do it. Taking out the bivariate analysis. Okay, and if missing values are there, okay, find out the skew is there or not, find out the heat maps and other things. That is your learning part. So you can apply all the techniques of the EDA here before putting the data to the model. Before putting the data to the model. Now here I am doing, see here, I am coming here. Now if I check x.shape, what is the shape here? It is saying 569 rows 30. So you have to check your outliers also, box plot and many more things. You can do it. Later on you can add those things for your own learning purposes and practicing purposes. Shape y is there, 569 is there. We can reshape it if it is creating a problem. Okay, so that one column, many rows, -1 means many rows. Many rows, 569 rows are going and one column is going. So certain time it creates a problem for the NumPy array. That's why, because it is getting the value into the scalar mode, it is not getting the value into the two-dimensional data. So we do reshape it. Okay. So why? Now I am doing the train test split. I am using a XY test size. It means 20-80%. 22 means test size is 22 means nearby 20-80%. Right? You can write a 0.20. That is up to you. Random state. Today I am making you understand how to change the random state and why we are changing the random state later on. Now I'm checking out the train X and train Y data. What we are doing it here? Train X, train Y. Train X, train Y. So how many it is splitting? 443. It means one can understand with this data. Just a moment. Here, in this way. 443 and 443 here. And here 426 for the rows. Getting? And here 443, 30 columns are going, students. And here 126, 30 columns are going. Getting? Okay. Now what we are calling the logistic regression. We are sending these two data where lg.fit, logistic regression.fit. Getting my points? Then we are doing what? 126 rows are going for the testing purposes. So for the predicting purposes, how many are going? 126, and it is predicting on its own. Right? Now here, if we check, I am checking the accuracy score. So I am sending the predicted one and the original one. Okay. How much is this showing? 0.95 means nearby 95%. Okay. Means nearby 95% system is working well. Now I am checking out what? Confusion matrix. Into the confusion matrix, I am sending the test Y and the predicted. Okay. So it is just showing you confusion matrix, your actual and the predicted. It is just showing the cases here. 43 cases with no cancer, 77 cases with yes cancer, and 4 cases are doubtful cases. Here 4 cases are into the no, and 2 cases are again doubtful cases. Getting? So this your 43 by 43 plus 4 is your recall sensitivity, and this one is your precision, 43 by 43 plus 2. Okay, and this one is a specificity, means this one is that 77 cases are there, so it means 77 divided by 77 plus 2. This one is the specificity. Now the point is that if we check out all these things instead of our mathematics here, we can see it here. Precision, recall it is sending, and it is just making out what? Yeah. F1 score. So what is the F1 score? 2 into precision into recall divided by precision plus recall. Okay. So it is just giving you that precision and the recall value and the F1 score for what? 0 or 1. So it is just saying support 47 is what? This one is the total support. So this one. Getting? For the 0 cases and for the 77, these cases, how much for the 1 cases? 79. 79 cases are for the 2 was the false cases, and for 0 cases for the 47 cases. Though it is into the error cases also, does not matter, that happens. Okay. So what is the F1 score you are getting? 0.95 if you check it out, this only. So F1 score is your model performance. F1 score is what? Model performance. Getting? So your model performance. So how much is the model performing well? 95% model is performing well. And you might be knowing accuracy score is a subpart of F1 score, model performance. So here we are getting, okay, what is the model performing? 95% of model is performing well. Okay. And accuracy score is a subpart of automatically your model performance. So what is the accuracy score? That was a 43 plus 77 divided by 43 plus 4 plus 77 plus 22. That is a subpart of it. Okay, so in this way, do we do the what? Logistic regression. So simply we are taking out the data set, we are using the logistic regression, we are doing the EDA process, then we are putting the data into the logistic regression, right? And then once the data is learned, the model is learned, then we are checking out the matrix. So right now 95% model is working well in this case. Getting? So this way it is. Okay, you can note it down. Take it. Do it, and you should remember, see students, later on you have to do these one. Suppose this one is there, here you are checking it out. After this means after it, once you put the data into the data frame, now once you're putting the data into the data frame here and here, now you can apply many EDA processes, because you know that there are many pandas methodologies also, and one can apply the C1 methodologies also for doing the EDA. So later on, you can apply the EDA process. Okay, that is your learning part now. You have to evaluate everything with the data set and later on training the model. So you have to add on your own later on your own EDA process. You have to do. Okay, that is your practicing now. And be careful for the spellings. Do put the right spellings here. Okay, done everybody, please. It's already too much time, please. Done now? So are you able to understand that when we are applying the logistic regression, whenever we are looking for the output variable in the form of yes or no, only two categories are there. Yes. Okay, tell me one thing. You tell me, suppose, wait just a moment. Here, suppose random state is 42. So basic is, what is random state? Random state is a seed. This one is a seed number which will give you, which will be automatically picking the different rows for the training and different rows for the testing. So suppose 42 is there, for example, maybe at 42, for an example, I am taking 1, 2, 3, 4, 5, 6, 7, 8 rows are there in total. Okay, so one has to select it for the training and for the testing. Suppose 42 says that row number 1, 3, 5, 8, 7 will be selected for the training and 2, 4, 6 will be selected for the testing. Okay, so then we are doing the we are training the model and we are checking the accuracy score and classification report. Then maybe I am changing this 42 to now 45. This one is a new seed number, and maybe this new seed number is saying that for the training just pick the row numbers 5, 6, 3, 2 and the remaining one for the testing. So it means your random state is a seed value which is giving the row numbers to pick for the training and for the testing. And this seed value will give different row numbers for the training and testing in different machines. My PC, it will take a different row numbers. In your PC, it will give a different, because it's a random number. So that's why everybody little bit results could be fluctuated on the machine. So now what you can do, just suppose right now, suppose in my one, I am having the accuracy score. You had also checked 0.95 I am getting. Okay. Suppose I want to improve with this accuracy score 0.95, I want to improve it whether I can reach up to 0.97, 0.98 or 1. Okay. So what I can do, this one is I can change this random state. So this one is a hyperparameter tuning, we call it. Yeah. So what I can do now, what you can do, students, this you can change it, because we do get the best value between 42 to 55 nearby. You can apply it, you can give any number, does not matter. Just it is taking out the number. So what we can do, suppose 42 is there, what you can do, students, you can change this 42 to 45. You can change it to 42 for 45 right now and click on cell and click on run all. So it will be re-evaluating the data set with a random number 45 and see whether your accuracy is improved. If my accuracy is 0.95, so suppose I am changing it to 45 and I am going to cell run all, right? So that I can see whether my accuracy is improved or not. So right now I am getting a 0.95 now. Let's see. So one can change it. One can change it more. If it is below, then you can again change it 0.94. It is saying 0.94. It is low down. So I can again change it. I can go to 47. I can go to 50, 55, and let's see at which point I am getting the highest point.
0.96.
Okay.
And what is the maximum value of the code?
No, there is not as such. You can keep on testing here.
Testing rate would be
0.95.
45 to 50, in between 45.
It could be 30 times. If you are taking it 30, just to give the random state 30. Test it.
And 40 is 0.96.
Here at 47, it is giving 95 here. So I can change, let me change it to 48 or 50. It's just a seed value. Let it pick certain row number on its own for the training and testing to improve the results. Here it is 96 at 50. You can see at random state 50, it is giving 96 here. 96. Getting?
Yeah.
So it means you can keep on changes if you feel it so to make the model learn more well. Test size is nothing. The test size is just how many rows you are sending for the testing purposes only. So if we are saying, because see initially if 22%, it means 80% we are sending the data for the training and 20% for the testing. Changing of the test size will not improve the result. You can tune it from random state. This is known as a hyperparameter tuning. Hyperparameter tuning. Parameter tuning you are doing it with different values. So you can change it, these things, between 30 to 35 or 60. Generally we do move it to the 55 because generally we do get the values between these ranges available. But you can take any value, you can see at which place you are getting the highest value. So they try to reach this model up to 1 also. It means 0.99, 0.98, 1.0. So you can keep on random state changing. Okay. And there is one more methodology. Directly you can apply the for loop here. One can apply the for loop, right? One can apply the for loop completely, and into the for loop one can give the random size with the different values, right? And one can see at which level you are getting the highest one. Okay, so this one is the case for the basic logistic regression. Getting all of you? Everyone is okay up to logistic regression? Yes, students? Everybody? Okay. So the point is there that see, there are certain cases. Okay, now let me tell you certain more things. Yes, there is a UCI machine learning repository. UCI machine learning repository where 500 datasets are given. UCI machine learning repository where 500 datasets are given. This UCI machine learning repository is maintained by California University. Okay. So all the real wide data sets are given by the various industries, healthcare sectors, real estate sectors, okay, banking sectors, and many more sectors have given their own data sets for the research purposes. So here one can go with the UCI machine learning repository and you can find out the data sets. And here, if I'm going to the UCI machine learning repository, one can find out 500 data sets here. One can see popular data sets, see here. Many data sets are given there, here. Okay. And so many people has used this data set. These are the hits. 3,92,000 means 3 lakh people, means nearby 4 lakh people has already used it. It means one can see that how many people are working on the data science. Okay, and how many people are using these data sets for the learning purposes of, one can understand well the role of data science now. Okay, so one can see there are many data sets. Let me take out one of the data set here. There is one of the data set, concrete data set. Concrete, see this one I had mentioned, concrete data set. So concrete data set is there. Here it is mentioned concrete compressive strength. Concrete compressive strength here. So here inside the concrete compressive strength, when I'm opening it, or I can directly write it here also. Suppose here I am UCI machine learning repository, I can write here concrete data set. Concrete data set. Okay. Directly I can move to the URL of concrete data set. Okay. Now there, if I'm moving it here, that is again into the, you can see here, see machine learning repository, Center for Machine Learning and Intelligence Systems. All the data sets are real time. Okay, because one cannot make the data sets. It's not possible to make the data sets. There are thousands of rows, 2,000 of rows, 10 lakhs of rows are there. Okay, so let me tell you about the concrete compressive strength data set, what it is telling about. It is the real estate data set where one is making the mixture of building ingredients. Concrete means one is making the masala directly. So now the point is that how to test, suppose one is making a 50 floors. What standard concrete set one has to make. It is not just like here in India one is doing and one is putting everything at any, like one cement with 10 Badarpur and these things are going on. That is not possible here. One has to go with the standard things. Okay, so here how one is testing that particular ingredients of concrete to put it for the building purposes. So here it is not possible to add all the things physically and then testing them. Okay, because they have to make it into bulk. So in that case, here one has to put the values. Okay, to put the values here. So one can see here concrete compressive strength. So one can check out the values and test out what could be the strength of that particular concrete set which can be applied to the building. So here concrete is the most important material in civil engineering. The concrete compressive strength is highly non-linear function of age and ingredients. It means if your concrete is old also, you will never get the strength. The cement should and other things should be new. And other ingredients also. Whatever ingredients are being mixed into the concrete set. So that is highly having their own ability to make the concrete strength very much fixed or a good one. So here one can see data set characteristics, multivariate means multiple variables are there. Attribute characteristics means all the values are real time, real decimal values. Okay. How many instances rows are there? 1030 rows are present there. How many rows are there? Okay. How many columns are there? Okay. Missing values null. Okay. Somebody has donated. Okay. Now see here. One can see web hits means nearby 2 lakh people has already hit it for the usage of the data sets. One can see the popularity. Now, what type of task we are going to do? Okay. Now coming here, data set information is given here. Number of instances, number of attributes, attribute breakdown, 8 quantitative input variables and 1. One should know that what is the output variable, one should know what is the input variable. Then only you can segregate the data into X and Y. So here one can see given the variable name, variable type, the measurement unit and the brief description. The concrete compressive strength is a regression problem. The order of the rating is order of numerals along with the rows of database. So one can see what could be the different columns. Cement is what? Blast furnace. Fly ash, water, super plasticizer, coarse, fine aggregate, age means how much old is there. These all are what? Now what is mentioned there? Concrete compressive strength. Okay, and what is it? Target variable. Okay, so one should know that what you are going to do with the data set. Directly take the data set. If make the ED of the data, upload the data set first of all. You have to upload the data set where? We have to go to the data folder. Inside the data folder, see here, it is mentioned there. What is mentioned here? It is what? concrete data.xls. It's into the Excel file. You can, if you are downloading it, it will be going to your local file downloads. From there, you can upload it into the Jupyter notebook. And if you're uploading it to the Jupyter notebook and you're calling it, so you can call it with a, like if it is a CSV, we call it a CSV, read CSV. If it is XLS, we can call read_Excel. There are methods. Even you can explore your pandas also from the Google. Remember, you should be having exploring capabilities also. If you want to find out the methods, that if it is Excel, what method you are going to put. So directly read Excel, read_Excel. Still, if you are finding the error initially, directly write into the pandas. You can go to the pandas read data. You will be finding that library, read Excel. So you can read the documentation of the pandas also, that how to call the Excel file. Okay.
Either you can download the .txt file also.
No, don't use the text file because you are not aware how to handle the text file. So here you are going to work with the CSV file or the XLS files, right? So you have to upload it with the read Excel or for your convenience only. That is completely up to you how you are doing the things. So even concrete data, those students are not who are not aware with the Excel, so directly they can save as it as a concrete data.csv.
Yeah.
And then call it with a read CSV. That is up to your technicality, right? So you have to call the data, then you have to make the EDA, exploratory data analysis. You will be doing it.
Reading Excel. It will be
Doing the EDA process, that one is a primary process now. After doing the exploratory data analysis, what you are doing, you are finding out, you are fetching out all the null values, you are finding out the outliers, removing it. If you're finding out the correlation, if you want to drop certain data, you can drop that, and then you are handling the null values also. So you are doing the pre-processing also.
yes.
Okay, and then once your data is ready, then you are sending the data for what? For the training purposes and for the testing purposes. So you are making the train test split, and now it is your duty to take out the X and Y variables separately. And you should be knowing that for the X and Y variables, here you should be knowing clearly that which one will be the X and Y variables. What you are finding it out. And whether you should apply here the regression or the classification. Regression or the classification here. Clearly mention each and everything here. One can see in the problem also what is mentioned here. And one can see what is the output variable. And if you are having all the quantitative, it means decimal values are there. So one can think it on your own also. That directly what you can apply. Which ML you can apply directly. Okay, so you can load the data set, then you can do the EDA process, then you can pre-process the data, handle the null values, okay, removing the outlier, removing the skewness into the data, making the univariate and bivariate analysis, okay, checking out the data types, everything, and then once your data is ready, then you have to send the data for the training and the testing purposes and checking out the matrix then. Oh, and see here, this one is a regression. So you have to know that which matrix you are using, R2 score and mean squared error. But if the problem is related with the classification, there you can use what? There you can use for the matrix, accuracy score, confusion matrix, and the classification report. And you should be knowing if you are using a linear regression, directly which one you are going to use. Linear regression. sklearn.linear model, import linear regression. If you are doing the logistic regression work, import the logistic regression. That you have to frame in your mind that what work you are doing, what is the data set, how it is looking at data type, and how it is coming here. This one is one of the case here. So now see, I'm just showing you only so that you can well understand with it. Just a moment. See here. This is a task I am giving to you. You have to do on your own. You have to do on your own completely. Just I'm giving you a glance only. Okay, otherwise each and everything, if you are typing it from here, then you will never learn anything. You are 100% dependent. You will not write a single line there because you will not never remember. You are simply seeing here, looking in your Jupyter notebook, then how you will be practicing on your own. So you have to do all the work on your own now. Getting the point? So that you can remember the points, you can evaluate, okay, why I am using a linear regression, why I am not using a logistic, which matrix should I use, how to remove the skewness, so that you can keep on learning, otherwise you will never learn the things. Getting the things? So here it is like here I'm giving you the glance of the data only. So what I did, I loaded the data, concrete data, and for the sakeness of you, I just changed the data into the CSV file and uploaded it. But better you can directly upload the real Excel. Okay. I am putting the data into the data frame. Okay. I am checking out the shape. It is just showing 1030 rows and 9 columns. Data types I am checking. What is the data type? It is just showing all the data into the float. Mean quantitative data are there. All things are quantitative. Directly I can apply the regression directly. Because I want to see what? I want to find out what is the concrete compressive strength. So I can't measure it as any logistic problem. I'm just directly looking, okay, certain regression problem is there. Okay. I'm checking out the information completely. I'm checking out the columns here. Okay, many columns are here. One can see here cement, blast, fly ash, water, superplasticizer, CAFA, age means how much old it is, and CMS. So directly I can understand from when I had downloaded the data, when I had studied the data set completely, I came to know that these are the X and concrete compressive strength. Okay. Now I'm finding out the describe also. It is just showing me that what is the mean and what is the standard deviation, 50th percentile, 75th percentile, and maximum. From here also I can check out the outliers by checking out the standard deviation. If there are too much standard deviation, one should know that outliers are present. And checking out the 75th percentile and the maximum also, we can find out that yes, outliers are present into those particular columns. Right. Then I'm just making it out at a quick glance that certain age, plotting out with a box plot also. I want to plot everything into one so that every data could come into the one row. Okay. I'm checking out the heat map also. Directly here I'm checking out there is no null values, but if you find out, you have to handle that part by giving them, replacing them with the mean median. Right? Here I'm checking out the correlation of the data. Heat map I'm generating, and from here I'm getting, I can check it out that from here that I want to find out the CMS. This was the Y, and these all are input here. So that is okay. Rest of the things I can check it out. These are negatively behaving, water and superplasticizer. This one and this one very negatively. But I have to find out CMS. So let me check out that which particular column is reacting very negatively. Is there any black zone here? No. No black zone. Means some of values are here, -2, like water is there, -0.2, -0.17, -1, that is okay, but none of them is coming into the black. Because see, to make the concrete, everything is required. I can't eliminate the water, I can't eliminate the superplasticizer from that solution. Otherwise, how can I make the solution? Getting the things. So here I am getting that yes, everything is having the correlation, but I can't add high water also into the solution. There should be a proper proportion of the water. There should be a proper proportion of the cement. There should be proper proportion of the superplasticizer. Everything, right? So in that way. So if I found out the things very negative, that I can think, okay, maybe I can lose this because it is behaving very negative into this data sets. Okay, maybe it will affect the model. Lovely. So okay, from here I'm checking it out. Then I'm just checking out the skewness of the data. If I'm plotting out the age, it is just showing a little bit skewness. If I want to improve the skewness, because this one is a right tail skewed, so I'm just doing the log transformation. Okay. so that maybe the skewness should come into the normal distribution and my data set could be improved for learning of the model. Okay, so suppose this one is a right tail skewed. If it is there, we can use the log transformation or the square root or cube root. Or if it is a left tail transformation. So here we can directly cube or square the data. Okay. For this, kindly do see the applied machine learning repository. That is a personal duty to complete the applied machine learning repository on your own. That is very good LMS course. That is mandatory course because there are many things applied there, each and everything. So once I had applied the log transformation, it has improved with the normal distribution. Okay, the age data has been improved here. I can now you have to extend it because I am not doing each and everything here. I am not going to do each and everything univariate and bivariate analysis. You can do it. You have to do more univariate by one column. Just see it with a different dist plot and other plots also, skewness check and other plotting also you can do. Okay, and now I am doing the directly pair plot. Okay, so here I am checking out is that data skewness and linearly the data is available linearly with other things. So like suppose this is there, so it is just showing linear data. Getting? See this one. Cement and CMS. Linear data are there. It means that if more cement is there, the concrete compressive strength is more. Okay, so in that way, water is there, but higher water value will not be affected. More water I can't do. Okay, if I am adding more water, you know very well what will happen. So in that way, it is just showing normal distributed data here. So in that way we can do it. Then we can handle the missing values. If I am finding out if there is a missing value here, so I can use from df.replace also, and I can use the sklearn or pre-processing import imputer also. There's an inbuilt. One can use the imputer to impute the missing values for the mean, median, and strategy, and directly df.replace. That will also replace the null values. Any of the methods which you are comfortable, you can use it. Right? Whenever you want to see more detail, directly go right onto the Google sklearn, scikit-learn.org, and from there you can find it out. Right? Once the data set is ready, see here, my data set is ready. Right? Now my data set is ready. I am doing what? I am finding out what? With this, I am finding out what? I am finding out what? Why I am finding out the next location? I am finding out the target. -1 is last one. So here it is. Yes, good, Rahul, good. Here is the last one, na? Where it is the last one? This one is the CMS is the last one, na? So this one will be the -1, last one. So for the y variable, I am finding out the, one can see I am finding out the -1, checking out the shape, and here I am checking out what? I am fetching out what? Here I am doing what? Now you should answer me, students.
From starting to the
Data. Exact, Rahul. We are fetching out the X data. So one should know this one is the X data, and from 0 to 8, all the X data we are taking. If you want to drop it, that you know, that is up to you. So and here I am taking out the -1 means the y target. Target means CMS. I am looking it out. Okay. And then what we are doing, you know, shaping check and training, X train and Y train, you know, splitting of the data, and then what we are doing. Okay, checking the coefficient intercept, and you can check out the R2 score, mean squared error also. You have to do everything. If I am skipping the steps just for the sake of you, because if I am showing you everything, you will just copy and paste and you will not do anything. I know that. That is, you are into the habit of that one. So here, coefficient interception, now I am doing the prediction here, right? And with the prediction, it is just giving me the answers. You can match out the answers here. It is just giving the score here by 77. Okay. And later on, I will check because see, the difference between the score and the R2 score you will be getting, because this one is an X-train and Y-train, means question and answers are written. So anybody can do at that time. But at the time of paper, you will be getting the result a little bit low. So that's why R2 score is little bit low. Because R2 score is coming from the predicted result. Okay. So here I am showing you this one. Now here I am checking out what? I am checking out the mean squared error, and you have to check out the R2 score also. I am not going to show you now here because you will again do the same things. You have to remember that okay, in linear regression we do these things. Okay, I have to check the R2 score also. And you have to write that library. You have to call that library now into the matrix from sklearn.matrix import mean squared error comma R2 score. So that you can just learn, you can read the things, otherwise you will not read anything. Directly copying and pasting is going on. Okay, so here mean squared error, you can call it here also. Suppose here it is R2 score, you can call it here. Okay, so that you can learn okay how to call the R2 score. Getting the point? Getting the point? And then what I am making the predictions also with the new values. Right? So in this way, this way you have to do the concrete data set. Number one, you have to do on your own completely. Okay. Now I'm showing you the second one. This one is a concrete data set. Okay, just a moment. Now this one will go for the regression purposes. For the losses, there is one more data set. Many data sets are there. Let me tell you. Wait. Here, wait, UCI machine learning repository. Okay, remember inside the machine learning repository here, there is a Ballon data set, a Ballon data set. A Ballon data set is no, not this one. Wait. Here, okay. Wait. A Ballon data set here inside the Ballon data set. A Ballon is what? It is just like a tortoise species. A Ballon is a species which lives nearby lake or water pond. And here, what we have to do, here we are having a 4,177 number of rows. And number of instances, number of attributes are 8. Okay. Predict the age of a Ballon. Predict the age of a Ballon from physical measurement. So actually what is happening here in a Ballon, it is saying there are number of rings on the body of a Ballon. From that number of rings, one can predict the age. It is just like a tree. Or tree that is a number of rings are there. Okay, so from that particular number of rings, one is predicting the age of that Ballon. Right now, here it is classification, but I will convey to you that you do it with a regression. Number one, initially, because I can take any data set for any purposes. Okay, now one can read here. See here, data comes from original study of these people. They had studied the data, and okay. Now here you can see here predicting the age of a Ballon from physical measurement. The age of a Ballon is determined by cutting the shell through the cone, staining it, and counting the number of rings through a microscope. Okay. Now here attribute information means data information. What it is saying, given is the attribute name, attribute type, and many things. Here see students, every time nobody is conveying you that what is the input and what is the output. Because in the industry no one is going to assist you. So that's why from here only you have to make yourself practice that okay, if this is the data set, how can, because what is the statement given there? The statement is given here, predict the age of a Ballon from physical measurement. Okay. And what it is saying here into the new statement, it is saying the age of the Ballon is determined by cutting the shell, sitting out the cones, and counting the number of rings. Okay. Now from this data set, you tell me on your own defining that what could be here. What if I am a layman? Okay. You tell me that what could be the Y here. Okay. And many other students, what could be the Y here? What could be the Y here? You tell me. Students, I am asking from you, please. You tell me what could be the Y here. Nobody is responding. Why? Yes, Prakash, Mahesh, Sanket, Amrit, Abhishek, you tell me what is the Y here. Clearly, I tell you right now. Huh? Age? Here, nothing is age is written. You tell me what is the name of the output variable here. What is the name of the output variable here? Where is the shell? No, it means you are not reading the statement properly. Yes, Amrit. Yes, and what else? Everybody? Mahesh, Prakash, huh? And what about other people? Okay, Sheshi, other people also. Abhishek Mishra. Who is Abhishek Mishra? Okay. Okay. So here the point is that how you're getting it? Because see here rings is given here clearly. And are you reading it? Yes, Rahul. The number of rings is the value to predict. Either as a continuous value or as a. So right now, do not take it as a classification for the time being because you are not aware with it. You are aware with the logistic, with the yes or no values. So you have to write it with the regression problems here. Continuous value, so you can take it as a what? Y and all these as a X. Now the point raises here, you can check out these are the continuous values. See, continuous. But what about this one? Whenever we are talking about the gender, male, female will be there. So in that case, right now you are not aware how to evaluate these case. If M, F, you will be getting the data as a M and F. You are not having the values there. So right now, because you are in the learning stage, you are not aware what to do with it. So what you do, you drop the data. Which one? You have to drop these gender values. You can drop this column so that you can learn how to drop the columns as well. Take the data set. Right now, if you're finding it out, okay, just to make it only with the numerical values because you are doing the regression. So directly you can just drop right now. But later on, again, you have to do this data set while handling these type of data also. Okay, so these you have to do it on your own. So a Ballon data set, concrete data set you have to do. Okay, I'm taking the third problem here for the classification purpose here. Inside the UCI, there's a very popular data set, sonar data set. Sonar data set. This one is a submarine data set. This one is a naval data set, Navy data set, sonar data set. So in this data set, one can see it here. See here, this one, connectionist, plan, sonar, mines versus rock, UCI machine learning repository. Are you getting? archive.ics.uci.edu. Okay. Sonar data set. See, I typed only sonar data set. Here, if I'm doing it, I'm going to this one. Sonar data set. One can see inside the sonar. Let me talk about what is the sonar data set all about. This one is a real-time data set given by the naval submarine data set actually. And here inside the submarine data set, actually see, whenever submarine is going, so they have to detect every time that there are certain type of obstacles coming on the path. Now there could be rocks and certain time it could be enemy mines also. Enemy do put the mines to blast the submarine. Maybe you have seen certain movies also come for the same one. They have to fail that particular mine. The latest movie is also there based on to this one also. This one movie two years back. Okay. So actually, the people in the submarine, they are continuously detecting the obstacle coming into the path, and those will be detected as what they do. They send the signals, and when that signals reflect back, they measure the values. And based on to the values that is coming, that whether the coming obstacle is a rock or a mines, explosive mines. To be onto the safer side, this one is a big data set that is having a 208 rows, 60 columns are there. And what could be the problem here? Classification problem, one can understand. But every time I'm conveying, and nobody is going to tell you it is a classification problem. You have to think it from your own mind. That what you are looking for, what you are finding, and what it should be, in which phase it is coming. Continuous value, directly apply the regression. Okay, classification, two values are there. Okay, apply the logistic. In that way, you have to think it on your own. Nobody is going to convey these things. Right? So you have to evaluate that. Okay, what you are looking for. So here into the classification, you can see the data set was contributed by the benchmark collection of certain person, Salk Institute and University. The data set was developed in collaboration. Okay. The sonar.mines contain 111 pattern obtained by the bouncing sonar signal of a metal cylinder at a various angle and various condition. It has taken the 77 patterns from the rocks under the similar condition. The transmitted sonar signal is a frequency modulated chirp, pricing and frequency. The dataset contains signal obtained from a variety of different aspect angles. Okay. Now it is saying that inside this dataset you can see here the label. You should understand with a single bit only. The target, the label, the output, directly one should understand. Okay, no, because no explanation will be given there. The label associated with each record contains the letter R if the object is, and M if the object is mine. The number and the labels are increasing order. Okay. So it means one can understand that inside the sonar data set, one is having what?
Y attribute.
Inside the Y attribute, what you will be having?
R and M.
R and M. So what you can apply?
We have to go with the logistic. Logistic. Yes, sir.
What you can apply there? If R and M value will be there into the label?
Only logistic.
So from here you have to fetch out sonar all data. This one. Sonar all data. This one. This one you will be fetching it out. This one. Okay, sonar all data. And remember one more thing, it's a very large data set because 60 columns are there. What you have to do, students, once you are for your safer end, what you can do, just to download it, it's a big data into the notepad. But all data is there. So what for the initial purposes, because you are into the academic series only. Control A to select all the data. Pull all the data. Okay. Okay, all data is there, or directly what one can do, already directly take the data and load it into the Python text file and save it as a .csv, sonar.csv, or from here only once you download it, just to change the extension, sonar.csv instead of .data, because it's a text file. If you will upload the text file, it will not read, because system will read your CSV file. Pandas is reading the CSV file or Excel files there. Okay, so once the data is into the format of CSV, then you upload it into Jupyter and call it into the. Then on your own mind, just you have to fragment what? You have to think it that how the data is coming. You can make your own analysis, means what? EDA processes, right? If you're thinking it could be a regression problem or it's a classification. Find out your X and Y after doing the EDA preprocessing, right? And then make a train test it and make the model learn. You should learn that whether you are using a regression or the classifications there. You know now what should be applied? And in the Y, if it is coming into R and M, rock or mine. So you have to make it separated into the variable label, target variable, and then directly work. Make the model X and train and Y train. No need to drop anything here for the current purposes, for the initial purposes. Nothing to drop. Do not think that it is into the R and M we can drop. No. As a Y, it can come into the R and Y. R and M. It can come into the letters. Does not matter at all.
X we can
Into the X, the data should not be into the categorical alphabet way. So string data, but into the Y it can come. So for the initial purposes, I'm giving you these tasks. These are the practice projects you have to do right now. Concrete data set, a balloon data set, sonar data set, these three data set, just evaluate on your own for with your own thinking purposes. And remember, you will be getting the errors every time. No one is perfect. Even we don't. We are learning with the errors. You have to think what you are doing. And certain time which you are getting the errors, now the best way is just to find it on the Google also. You can find it out. Does not matter. Because there are lakhs of people are learning and they are also getting the errors. Right? So try to refine on your own. That what mistakes you are doing it. And in second time you will never repeat the things. If once you are done with it. No? Okay? In that way only person can learn. Okay then for today, thank you very much. Okay, so you have to do on your own. So first of all, what you can do, first of all, the best way of remembering all these things to work into the ML, the best way is make your own register, a big register, because you need a learning capability so that you can keep on learning. Because see, data science is not a small field; it's a wide field. It's a very big field. It is unending going on. So keep on, because you have to keep on learning those, every library, these things, methodology. So keep on learning is the best way. Suppose this one is a file, you created the file. You create the file, suppose cancer logistic you created. Okay, that is okay in front of you. Just to note it down in your big register, take a thick register. Do not take a small register, take a thick register, note it down each and everything. Once you are noted down with each and every, okay, then again open a new Jupyter notebook and write on your own. Initially with looking or with not looking, so that you can remember the syntax without any syntax error. Do the ADA process and apply your own critical thinking. In that way you can do it. So do practice with the cancer, do practice with the Boston house price, do work with a concrete, do work with a sonar, do work with a balloon, keep on working. Thank you very much. Thank you very much. Tomorrow is off already? Thank you.